And so we keep going. We've driven yet another mile. One more. Come on. Now we have exceeded the capacity of this counting system. We have used up 16 digits going from here to here, ignoring the fact that, right, we kind of leapfrog. We did a warp jump there. But anyways, he has to drop back from the highest value to the lowest one in the next increments by 1. So that one's a 0, and now we have that. Now it looks like 10, but 10 in hexadecimal is not 10 in decimal, right? 10 in base 16 is equal to, and if we counted them down, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's equal to 16. You're close. You just forgot that 0, 0 rather than, yeah. So, you know, this is equal to 16 in base 10. Kind of looks weird, right? But anyways, that's equal to 16 in base 10. And so 20 in hexadecimal is equal to 32 base 10. Well, how could I prove that? I could write out the powers of 16, right? We have 16 to the power of 0. We have 16 to the power of 1. I'm not going to do very many of these. And 16 to the power of 2. And so if we have the number 20, that's a 0 there, and a 2 and a 0 there. Well, what is 16 to the power of 2? That's 256, I think. And 16 to the power of 1 is just 16, and 16 to the power of 0. So if we were to write these up, that's no 256s, so 0 times 256 plus 2 times 16 plus no 1s. So 20 in hexadecimal is equal to 32 because 2 times 16. So if we have a long number like this, we're going to take note of the fact that if we have 4 bits of information, and forgive me while I type these, it takes a little while. You can kind of see the pattern though, right? Now we've maxed that one out. The first 3 bits have been maxed out, so when we start again, those are going to have rolled over, and we're going to be at that. What's next? What's this one? What's one more than 1010? Yep, 1011. What's after that?
1100.
Yep, 1100. Hope everybody's got this because I only hear one person talking to me. Maybe I'm just deaf, which I know is true. All right, and here we go. So if we were to count these down, that's, where's my mousey? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But using hexadecimal, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we're not done. We haven't maxed out our counting capacity because we can go all the way up to F. So A, B, C, D, E, and F. So if we have a series of digits like this, we can break them up. There's an easy way to convert this binary to hexadecimal just by clustering them in fours like this. I don't even have to know any math at this point. Once I have this table set up, I can go, well, what's an 0101? An 0101's a 5. What's an 0010? That's a 2. What's a 1001? See, I don't even have to be smart enough to say that's an 8 plus a 1 is making a 9. I'm just doing a straight lookup. Somebody tell me what an 01, well, we've already done 0101. What is it? It's a 5. Obviously, all zeros is a 0. And I made the mistake of not choosing any that are greater than 9, so they look kind of lame. So why don't we just start throwing in things, you know.
Oh, the last one's A.
Yeah, the last one's an A. Okay, so anyways, what is that one? All 1s makes a F. What is that one? A 1101 is a D. And this is an F. No, an A. All right. So this series of things right there, this bit sequence, in base 2 is equal to this sequence in hexadecimal. I could be a jerk and also make us convert that, into decimal, but it's too long to do, so I'm not going to do that. Okay, so clusters of 4 bits is enough to make 2 hexadecimal digits. How many is a byte? How many bits are in a byte? 8 bits in a byte. So every byte can be represented by how many hexadecimal characters? If it takes 4 bits, 2 hex characters make a byte. So a byte can hold up to 255 different values, which is more than enough to hold all the characters in a keyboard. Actually, 7 bits is enough to hold all the characters in an English keyboard, right? Because there's not 127 different keys, even if you count lowercase and uppercase. It's only when you start learning those tricks, like holding down the Alt key and then typing in some numbers. Like if I hold down Alt 166, it types in something funky, right? Whatever that is. Alt 167, right? Alt 168, well, anyways, once you're doing that, you're kind of cheating and using the keyboard for something, beyond what it was supposed to do. 127 different values is enough to hold the characters on the keyboard. But you have to have some encoding scheme so that you know that, if I type HEELO, what it's stored in is memory, how it's saved to disk, how it's transmitted over the internet. Even before computers, they had teletype machines, right? Just like in the, in the 40s or whatever. Spencer Davis and Katharine Hepburn sitting over the teletype machine learning the news from New York or whatever, right? Well, it was essentially a modem communicating signals down a phone line. Somebody types in something on one and it goes through the ticker tape on the other. They had to know that this little pattern meant an A and this little pattern meant a B and so on. So over time, by the 60s, people had solidified on a scheme called ASCII. ASCII stands for American Standard Code for Information Interchange. I believe that's correct. And it was a 7-bit standard because in the 60s, not everybody agreed that there was going to be 8 bits in a byte and stuff like that. Things weren't set in stone yet, but they knew that they needed 7 characters to hold all the uppercase and lowercase letters. So if we go to ASCIItable.com, we will see this coding scheme. So if I typed in an A, that's a hexadecimal 41. And if I type in a B, that's a hex 42. And if I type in a C, that's a hex 43. Does it have to be the hex? Do we have to remember that? Well, an A is a 65, and a B is a 66, and a C is a 67, and so on. You could do it that way as well. Why is it kind of neat to use the hexadecimal, though? Because if you're using base 10, then if they were going to type in a lowercase z, it would take 3 characters, 3 numbers to represent that if you're using base 10, but only 2 numbers if you're representing it in base 16. And it's kind of nice to be able to do that mental trick of doing that 4 bits equals 1 letter kind of thing. So, if I had this phrase, Abe, for whatever purposes, didn't mean to launch that, right, if I wanted to type in Abe bed, I could do that. I would pull up ASCIItable.com, and there's lots of tables. You can look up, you can just Google ASCII table, and you'll get a million of them. I just stumbled upon this one and I like it. So, I'm sure I'm getting a lot of text messages. I'm sorry about that. I'm going to try to bash this over on the side so that I can have both of them on the screen at the same time. Alright, so an A is a, if I look, if I can spot it, an A is a 41 hex. I'm going to put spaces here to make it easier to type. Okay, so an A is a 41. A B would be one more than that, so it's a 42. An E is one more than, not one more, that'd be a C. It's a 45. A space is a, well, I'd have to look. Oh, here it is. It's a 20. Notice the way it's set up. I typed in 30 while saying 20. Is that this first part of the table is control characters. So back in olden days when things were talking over, you know, phone lines or whatever. If you wanted to establish a communication, it'd be using all of this kind of thing in order to establish the communication. And these are all low values, you know, below 3.1, below 1F. So, you know, if it got a value and it was less than a certain bit value, it would know to look at these bits and to do something with it. Anyways, so then the real meat of the stuff starts over in this column, right? Spaces and punctuation and numbers. And then the really good stuff are the capital letters. And then the other good stuff are the lowercase letters and some more symbols. And if you look, the capital letters and the lowercase letters are 32 apart. So if you had it, once you press the shift key, it adds 32 to the number that's being saved out to memory. Anyways, okay, we figured out that a space is a 20, an E is a 45, and a D is a, have to look it up, is a 44. Okay, so, pardon me?
And the B?
I've goofed something up.
The B?
There, that's actually right. A B, yeah, thank you for catching me on that. That's a 42. Excellent. All right. Can I type? There we go. So, when I type this on my keyboard, in memory is this series of bits. When I do a file save, it writes these bits out onto the disk drive. If I type it into the search bar up here, right, you know, if I type in Abe space bed over the internet, this series of bits are sent. Now, I'm going to show you something here. I'm going to write that little phrase up here at the top, Abe space BED, and hit the carriage return. Because I didn't talk about what a carriage return was here. I did hit carriage return. Well, carriage return is one of these keys. It's a control key over here, just like tab. There's a carriage return and there's a line feed. And some parts of Windows like to see both of those, a carriage return and a line feed. And other parts of Windows are just happy enough to see a line feed and it assumes a carriage return. But anyways, I've saved my file. Not yet, but I'm gonna. So this is what, Lecture C, I believe. Why do I have two folders? It got me. Anyways, Lecture C .txt. Now I'm going to go to a different website. ASCIItable.com is cool. This one's kind of even cooler. hexed.it, which stands for hex edit. Hex editor. A hex editor is something that goes into memory and looks at the bits representing them as hexadecimal characters, or it looks at files on a disk. Used to be if you had an Apple II or a Commodore 64 or whatever, you'd use a hex editor to go in and change the files of your save files to give your Ultima character super stats, right? Or you could use a Game Shark for your Nintendo and make your character invulnerable, right? Something like that. It's the same kind of idea. So I'm going to go to hexed.it and I'm going to load up this file that I just typed in by clicking Open File, find Hex Edit, find Lecture C. And there's my ABE space BED. Now it's representing spaces as dots for some reason. I kind of wish it didn't. Makes it look cluttered. But anyways, there they are, our promised numbers, 41, 42, 45, 20. If I go look at my notes, it's exactly what I said they were going to be. 41, 42, 45, 20. And then 42, 45, 44. 42, 45, 44. Now what if I don't like Abe and I want to say that he's dead, not in bed? I guess I'm feeling kind of grim. I would take that 42 and I would change it to a D. What's a D? A D is a 44. So I could type in 44 here, and now it says ABE space DED. And our carriage return is a 0D, and our line feed is a 0A. That translation of needing both characters in Notepad is Macs and Linux and other forms of Unix do not use that carriage return pair. I think they just want line feeds. And so if you open a file that you transfer directly from a Mac or from Linux and try to open it in Notepad, it's all going to be one giant run-on sentence, you know, one long thing. But that's just a quirk of Notepad. Most of Windows just uses, you know, Control A, or, you know, line feeds. Anyways, so I'm going to save my data now. I'm going to do export Lecture C1.txt sounds good to me. Now I'm going to go and open that file. And I have changed it, right? So that's the correlation between what's saved in memory and what you type in. Now if you store this in a C string, if we said name is equal to Abe, then what happens? It goes and it allocates enough RAM to store that A and that B and that E, 41, 42, 45, but then it has to know how far to go, right? What to stop, where to stop at. And so it encodes one more thing, which it calls null. That's called a null terminated string. So when C is trying to print this out, send it to the screen or something, and when I say C, I mean C, C++, C#, Java, they all kind of work the same way just with respect. It'll print out an A, it'll print out a B, it'll print out an E, it hits a 0, 0 and says, okay, that's the end of the string, I better stop accessing memory at that point. So that's a null terminated string, 0, 0 meaning the end of the string. All right, just for giggles.
So,
You don't.
question.
Yes, sir.
The quotations that you put in there, does it also store memory for those?
No, it doesn't. That's a good question, but it's just assuming that if this is a string, the byte that it's pointing to, the first byte is the first character. And you could put quotes in there, but you have to go to some little difficulty to do it. And when we pop open Visual Studio, which I should get loading in the background, right, I'll show you how to put quotes inside a string so that they really are part of the string. But for now, if you would be so kind, you don't got to do this, but I'd like for you to do it. Pop open Notepad, and let's type in a phrase like bad space data. And using ASCIItable.com, type in the hexadecimal values that make that word. I'll give you a moment to do it. Right, just go to ASCIItable.com. ASCII is ASCII. You could totally cheat and load up hexedit.com and type in bad data and then read off that. But we're not going to do that. We're going to use ASCIItable.com. But I'd like for you to give it a shot. You know, give you a minute to do it. Alrighty. So somebody start reading them off. What's the first one?
42.
That's a 42. And what's the A?
41.
41. What's a D?
44.
44. And what's a space?
20.
20. And that D is another 44, I think. And then another A is a 41. And what's a T?
54.
54. And then lastly, an A is a 41. So this is a hexadecimal value, the hexadecimal equivalent of the bits that are stored in the computer when you type bad data. It can be a little bit more complicated than that because that's ASCII, but ASCII isn't enough to hold Russian characters and Japanese characters and Chinese characters. You know, some of those alphabets have, you know, hundreds of symbols in them. You know, the Asian alphabets have lots and lots of symbols, and they have a simplified version so that you can use a typewriter keyboard, and then they have the more complex written symbol, right, where you pictograph, you know, represent, you know, a different word, a different symbol for every word. So, and what about emojis? Now my phone has like 400 different emojis, and each one has to have its own code. So now there's a double wide character set that doesn't use just 1 byte to specify a character. It uses 2 bytes, called a multi-byte character set. And that way you could have, you know, Russian, German, and Swahili, and, you know, kanji, and Elvish, and Orc, and I don't know what all. Right. So that way you could have one editor that can read all that data as long as those characters are in the fonts. Used to be if you accessed a site in Russia, it looked like complete garbage. It just all looked like zeros and stuff like that because they were using a different character set. They weren't using ASCII. They would use something else where, you know, the A might be instead that upside down A and a sideways B, whatever all their characters are. And you had to change encoding. You'd go up to the Netscape menu and you'd pull down encoding and you choose Russia. And suddenly you could see the site. Well, nowadays that doesn't happen because they all use that double wide character set, which has the name Unicode. But when Unicode was invented, since there's so much text on the internet saved that was already written in ASCII, they kind of grandfathered the ASCII chart into Unicode. So in Unicode, an A is still that value, and a B is still, you know, that value and stuff. It's just double wide. So there'd be zeros in between everything. C by default, C and C++ by default are not doing Unicode, just like Notepad is not doing Unicode. But you can make it do Unicode if you want to. It's just a different data type. All right, let's get off the bit train and start doing our PowerPoints. I do have the PowerPoints loaded, I hope. Otherwise, we're just going to jaunt off into... Yeah, here we go. All right. I never recommend using the preview inside Canvas. If you have PowerPoint, I strongly recommend you use it because moving around in that thing is annoying. And I need to post the link where Rose students are supposedly able to download, you know, Microsoft Office apps for free. I haven't tried it recently.
I got it this semester.
Oh, you did? Cool, cool, cool. All right, live program, because it's awesome. Have we already done this?
Yeah.
Yeah, how far did we get? Let me see if I can spot how far we got.
We were looking at a grid. I'm trying to allocate bytes on it.
There we go, yeah. So programming and programming languages, a program is a series of instructions that forms a task. Those instructions have to be written in the correct syntax that a program will not compile. So you start off with an algorithm. An algorithm is not a program, it's just a description of a program. And you can have algorithms for all sorts of things. You can write an algorithm that calculates the value of pi, which is a weird idea, right? It's a mathematical constant. How do you calculate it? But you can, weirdly enough. We're not going to do that. An algorithm, a recipe for baking a cake is an algorithm. Calculating pay based on time and half or overtime is an algorithm. It might look like this, right? Input hours, input hourly wage, right? Set total equal to hours times hourly wage. This looks like a programming language, but it's not really. I couldn't paste this into C++ or Python and actually have it work.
We did this part as well.
This is pseudocode. Oh, we've already done all this? So you said that we were here. I think we're done with the chapter and I just didn't remember.
That stuff that we're going over right there, I don't remember. But we did go over the coding for hourly wage.
Okay, okay.
And I think we were supposed to do a homework assignment for ounces to gallons.
Yeah, yeah. Let's just take a stab and say that we're here. I don't think we got this far. So keywords, those are reserved words that have a special meaning. I cannot create a variable called int, int. I cannot create a variable called double or return because those are reserved to the language, right? They're part of the syntax of the language. So those are called reserved words, and there's like a list of 70 of them. We're not going to have to know them all. And if you've taken Python, then you're already familiar with the idea of keywords, you know. Like if and while. Those are all reserved words. Using, we've seen that one, namespace, int, double, and return are all reserved words. You can't use them in any other context, and if you want to get them to work, you better type them in the exact lowercase to get them to work. So program-defined identifiers is a fancy name for variables. But you can have other kind of identifiers as well. Function names are also identifiers. Class names are also identifiers. But for now, we're just going to say variable names are identifiers. You pick the variable names, right? If you want to call, you know, the place where you store somebody's salary, if you feel like calling it XYZ123, you can, as long as you use that everywhere through the program to refer to that value. It's not part of the C++ language because you're making them up. So if let's go ahead and start using Visual Studio now. I wish I could shrink the search bar down so that I wouldn't have to anyways. Complain. All right. I'm going to make a new file, so I'm going to need my boilerplate. So new project, C++, empty project. If you're using Visual Studio 2019 or whatever, you know by now how to do that. You just choose app type as being desktop, language as being C++, and then choose empty workspace. Lecture C. Sorry I spaced out on where we were. I usually depend upon the PowerPoint to be primed to right where we left off, and that time it didn't work. All right, so anyways, I'm going to make a new file, so I'm going to right-click on Source Files, do Add New Item, Lecture C.cpp. You never want to make your file names have spaces in them, just cause. Might work, might not work. Not going to risk it. Going to leave the spaces off because I know in some languages it does not work. So it's a C++ file. I'm going to go and grab the boilerplate from our class information under modules. And after a while, I'm going to stop talking through this process and just do it, right? Here we go. And please don't be typing all this in every time. You should only type it in once and then you should save it so you don't have to keep doing it everywhere. Okay, so what if I wanted to say int age is equal to 32 and then I wanted to write out my age? Right, so int age is equal to 32 semicolon. Now to write it out, cout less than age less than ENDL. I did not have to call that variable age. I could pick any name I want to, with a couple of exceptions. See all these blue words? These are the reserved words. These are the keywords. I cannot call this namespace, for example. I wouldn't be tempted to even, right? But I can't. So that's one rule for variable names. I'm going to go ahead and type those rules down here. I'm going to start a multi-line comment which begins with a /* so that I don't have to put // in front of everything. Rules for variable names, parentheses, identifiers. 1, can't be a reserved word, can't be a reserved keyword. 2, no spaces. I can't put int my space age, because it doesn't know the difference, right? It thinks now I have two words going on. If you like the look of spaces, you can use underscores. It's considered old-fashioned, but I'm old-fashioned, so you'll see me use underscores. For one thing, I think they're easier for y'all to see up here. What textbooks nowadays want you to do is to use what's known as Camelcase. Why is it called Camelcase? It's mixed uppercase and lowercase, and it's like a hump in the middle, right? Like humps, camels have humps. Anyways, no, I'm not going to do that. So no spaces. 3, they can be uppercase letters, upper and lowercase letters, numbers, underscores. You can use $signs, but they're non-standard. Microsoft lets you use $signs, but it's non-standard. So I wouldn't necessarily do it. I'm not going to even put it there. That's pretty much all that they can be, but that's enough, right? Anything you can name, you can use uppercase, lowercase letters, numbers, and underscores. And if you're French or German or whatever, and you want to create variable names in those languages, that works as well. Those letters work as well. But there's another rule. Cannot begin with a digit. Pretty much that's it. Yeah, sure, there may be a maximum length, but I doubt you'll find it. Maybe in old days, a maximum variable name would be 8 characters long, but that limit is long, long gone. So I don't even know what it is, and I don't think the book mentions it. So what are good variable names? My underscore age, right? That's fine. That's good. My space age is bad because it's got a space in it, right? My age with a capital A, that's good, and that's kind of the preferred modern looking syntax. Like I said, underscores are considered old-fashioned, but I'll use them anyways. You can just tuck that away in your head. Well, I want to be cool, so I'm not going to use underscores like my dumb old prof. So what about this? Tax rate 1980. Is that good? Yeah, that's good. That's totally fine. How about 1980 tax rate? Is that good or not? Well, look at this rule.
No.
It's bad, so we're not going to do that. And by the way, these are the same rules that you had in Python. So for those of y'all who took another programming class, you're used to these already. And would you be tempted to begin your variable names with a number anyways? Probably not. So are you going to hit these errors very often? Probably not. If you do, is the compiler going to tell you about it and make sure that you don't make the mistake? Absolutely. If I go in here, where's my, oh, it's right over here, isn't it? All right, so I'm going to end my multi-line comment with a /*. If you don't already have that there at the bottom, you're going to need that, right? All of this is just one comment. You know, if I get it wrong, like if I said one age, it'll tell me. It'll underline it. That's a mistake. And it'll underline the place where I was using it down here as well, because I don't have a variable called age anymore. So I need to fix that. Operators. Operators are standing by. No, operators are the math symbols, right? But there's more than just math symbols. Any of the non-alphabet things are operators, with the exception of the semicolon. The semicolon is not considered an operator. It's just part of punctuation, like periods are in English. So multiplication, addition, subtraction, and modulus, which is the %, those are all math operators. There's other operators, like the equal sign. I'm going to write a statement here, and then we're going to talk about where the operators are. So if I do this, if, parentheses, age equals 32, end parentheses, cout less than, yep, 32, exclamation point, \n, end quote, semicolon. There's several operators going on here. That's an operator. It's a symbol. What's the difference between a single equal sign and a double? This is called the assignment operator because it copies a value. It assigns 32 into age. The double equal does not assign, it compares. So that's the equality operator. It checks to see if they are equal. This is called a, it's got a weird name, stream insertion operator. I'm probably not going to use that name very often. I'm just going to call it less than. It just means take this data and send it to a so-called stream. Right now, the only streams that we're using are a stream that goes to the monitor, which is cout, like output, and the stream that comes in from the keyboard. Now, if we're using the stream that comes from the keyboard, I'm going to type this, but then I'm going to comment it out, because it would make us type something in every time we ran it. Oh, well, that was dumb. That's not what I meant to type. I was making a mistake even in something I was going to comment out. All right, right, and this means take the data from the input and store it in that variable. But now, if I keep that there, then every time I run the program, it's going to hang until I type something. So do I really want it there without the user knowing what it is, what they should type in? Right? No, I don't want to do that. So I'm going to comment that out. But anyways, that's another operator. There are plenty more. There's only a few places where an operator is something that's actually a word. For some reason, they call the word new an operator than a keyword. The book does anyways. I don't know. It looks to me like a keyword because it's the same color as all the other keywords. So what do I know? To me, the operators are the symbols. Math operators require two pieces of data to work, right? If I'm going to do age equals age plus 1 semicolon, this plus sign needs two pieces of data to work. It needs a 1. I mean, it doesn't need an age, but it needs two things on it, right? A before and an after. Plus is the operator. Age and 1 are the operands. It has two operands. Plus has two operands, required operands, two binary. So it is a binary operator. In this case, binary doesn't mean, it's all zeros and ones, because everything in a computer is zeros and ones. Instead, binary means it takes two pieces of data. Just about all the math operators take two pieces of data, right? If you're going to multiply something, you have to multiply two numbers. If you're going to, divide something, you have to have two numbers. The exception is the minus sign. You don't have to have two operators for a minus sign, right? I could just say -7. The minus operator here assumes, right, that there's a 0 in front of it if you don't put one there. So it can be used as a binary operator, but it doesn't have to be. If it's going to be used as a negative sign, it assumes it. And so something that requires only one operand, one piece of data, is called a unary operator. Unary instead of binary. Un meaning one. Guess we have to bone up on our Latin here. Anyways, binary operators, usually almost everything we see are binary operators. That thing is a binary operator because it needed two pieces, needed two operands. That's a binary operator because it needed two operands. So is that one. It needed two operands. If you just type 32, out here, yeah, that's great. But if you type equals 32 semicolon, there's going to be a syntax error because the equal sign, the assignment operator, requires two operands and there's nothing in front of it. Now, we wouldn't just type a number in out of nowhere like that because what's it doing? It's doing nothing. It's not strictly a syntax error. It's just useless. That is a syntax error, and it would prevent the compilation. I'm going to run it just to make sure I don't have any syntax errors at this point. Oh, and by the way, I think I said this in the past, but for the sake of all that is nice in the universe, if you get an error when you're compiling it, don't press do not show this dialog again. You want to know about the errors. And somebody did that, and I did not know how to fix that, and it was a real pain. Please do not say do not show this dialog if it's an error. Now, certainly the one that just is asking to change it, right? I'm okay with saying stop asking me that, right? Because I always want you to make it if I made a change. Right, that's fine, but not on the error one. Okay, I don't have any syntax errors. It's good to go. Anybody typing along and does have a syntax error that you would like fixed? Good time to pause. Anyway, good question. Good question. If you've done Python, you can do this, right? If x equals -7. No, this language is picky. You have to put the parentheses around it. But you asked about the braces if it's all on one line, right?
Yeah.
I was able to get away with not putting braces because I had a single line there. That's correct. The only time the braces are necessary is if you're going to do multiple things.
Is that a Visual Studio thing?
It's a C thing. You just got to do it. And the reason why is because Python uses tabs to indicate position. So that's fine. But this thing requires you to have the braces so that you don't have to tab things correctly. And that's so that you can, you know, it doesn't even care, right? I could write almost the whole thing in just one line, right? As long as I put my braces and semicolons in the right place. But it's just a C thing, a C++ thing, that if it's only one line long, you don't have to put braces. Quite often I'll put the braces there anyways because I think it looks nice and clean, right? But I wouldn't have to do that, and I could even do things like this if I wanted to. Is that good programming style? Most of the time, probably not, right? Your goal is not to cram as much code onto one page as possible. That's not really your goal. I will leave out braces on single lines like I did here because I do like to have as much code on the page as possible within reason so that I don't have to scroll up and down so much just because y'all are looking at it. If I was doing my own professional programming, I might go ahead and put the braces there. But I would not go as far as to do that under most circumstances. Makes it really hard to read. You're trying to write code that's pretty, that's easy to read, but you don't have to. Here, let me show you something. Obfuscated, which means something like hidden and garbled and stuff like that, C code. There's a contest, the International Obfuscated C Code Contest, where people try to write code that's impossible to read. So for example, see if we can find one. That one doesn't look that hard to read compared to many others.
Skates.
Here we go. That's wild. Just reading it, we have no idea what it's doing. And yeah, it's got these words, attack, regenerate, and heal, but it could be that the program absolutely has nothing to do with that. And, you know, it's not a game, and they're just doing, you know, the Lemon Lord. I guess that's the guy who programmed it. Anyways, right, you can write code that's absolutely impossible to read if you choose, but most of the time you don't want to. Most of the time you want it as easy to read as possible so that I'll give you a good grade and your coworkers will be happy with your code and it'll be easy for you to change in the future. Now, if you did that, I wouldn't count off, right? I'm not holding you to any particular coding standard. It's possible that if you're not using tabs and it looks absolutely horrible, I might ask you to revise it, right? Probably not. I rarely do that. But Visual Studio makes it so easy to keep things tabbed that I'd go ahead and stick with it. Now, you didn't have to type this example in your notes because all it was is an example of brace placement. If you left that brace out, you forgot you weren't using Python. What does this really mean? This means if that's true, then do this. But then again, it's going to do this no matter what, whether it was true or not. The mere fact that it's tabbed over doesn't mean a thing. So if this is true, it's going to do that, but then no matter what, it's going to do that. Because that's what the logic means. This is conditional and this is not. And the fact that this is tabbed, or if you put it there, see, this is really deceptive. Looks like those two things will happen only if the if statement's true, but it's not. Only this will happen, and this will happen no matter whether the if statement is true or not. So like I said, your goal is not to make the code as hard to read as possible. I would never put it like that. So punctuation, we've seen several different pieces of punctuation. That's punctuation of a form. That's punctuation of a form. And oh, by the way, you asked about strings. In order to use strings, I'm going to come up here, and we may as well add this to our boilerplate. I'm going to edit the boilerplate to have this. I would do include string like that. Include less than string greater than. And then I can use string data as well. So having that there, I could do something like string name, or how about f name for first name equals quote Bob, end quote, semicolon. And then maybe make a last name, L name. I don't usually like doing the lowercase l because it looks like a 1. This is a lowercase l. L name equals, Roberts. That's the dude's last name, end quote, semicolon. And what's his full name? String full name equals f name plus l name. Now there's a problem here. If I do cout my name is, end quote, less than, full name, less than, ENDL, is there going to be a problem? Yeah, there is. It's not probably going to look like what I want it to look like. My name is Bob Roberts, right? What's wrong with that? Why wouldn't a user want to see that? They'd probably want to see a space there, right? So we'd have to come in and do this. Now it's going to look pretty. Or I could have just put it inside my, no, I couldn't put it inside my print statement, right? There's nowhere to put it. So I have to put my space there. All right. What if I wanted quotes around the name Bob? Now this is getting a little bit further afield, but since we did ask about quotes and these character arrays, if I did this, it's not going to work. It thinks that is the opening of a quote of a string, and it thinks that's the closing of the string. I have to trick it. One way I could trick it is to use single quotes. That would be valid. Now when I run it, it's going to say, my name is quote Bob, end quote Roberts. That works. What if I really wanted double quotes? My customer said that he wouldn't pay me unless I had double quotes there. I could force double quotes by using what's known as an escape sequence. We've seen an escape sequence here, \n. Does it print out \n? No, it goes to the next line. \n stands for new line. But it's not the only escape sequence you can have. There's another one, tab, \t. It's tab. And so when I print it out, it's going to say, yep, tab 32. And there are still others. One of them is \apostrophe. That'll print out a single quote. Right? So there's a single quote there. Another is \double quote. It's called an escape sequence because it's processing it like normal text, but then when it hits a backslash, it escapes from that mode and enters a different mode. That's all I can come up with for why it's called an escape sequence. So when it sees a backslash, it escapes normal mode, and its next behavior is determined by the character that follows the backslash. Well, that gives us a little bit of a problem. What if I really wanted a backslash in my code? What if I wanted a backslash before my P? Well, if I put it there, it's not going to work because it's going to treat it as an escape sequence. And I don't know what a \p is supposed to mean, but it sure didn't print it. \\/ gets translated as a single backslash when it is displayed on the screen. That's good to go. Now it'll put the backslash there. So when I wanted those quotes around Bob, I could come up here and do \quote, B-O-B, \quote, quote. Now it looks funny until you're used to seeing it. But it works. It's totally fine. And when we print out Bob Roberts, the word Bob is going to have double quotes around it. Well, why do you care about escape sequences? Are you going to be putting quotes around things that often? No, but what if you had this? What if we had a file name? String file equals c:\temp \numbers t.txt, end quote, semicolon. And we wanted to print that out. cout file ENDL. ENDL, by the way, is the same thing as \n. Why don't I use the same thing all the time? My rule of thumb is that if I'm already inside a string, I may as well just type in \n. But if I'm not in a string, I may as well type that because it's easier to type that than put in a string \n end quote. But your mileage may vary. You could do either one. It would have been totally legit to do this as well. But why don't we just use ENDL because it makes the code look a little bit cleaner. I'm worried about clean code after having typed that. Yeah, right. But anyways, all right. So now when I print out my file name, C temp new file, okay, that's total garbage. Why? Because what are the /t's being translated as?
Tabs.
Yeah, tabs. And that \n was being translated as that. So I could use the double / trick in order to get it to treat these escape sequences as backslashes. There's another way to do that as well. And some of y'all may have done C# programming or something like that and can tell me the trick because honestly I don't forget it. There's a way to declare a string like that where you don't have to use the double / trick in order to get it to work. Any of y'all know? Sometimes a student does. Declaring a string in C++, ignoring escape characters. Got to be a way to do it. Is that the trick? You put an R in front of it? Let's give that a shot. I don't know if this will work. I'm just reading something from the internet. Okay, forget it. I don't know how to do it. I know there's a way to do it. I can't believe I've forgotten it. Maybe it only works in C#. Anyways, okay. So these are escape sequences. Let's back up and add some more notes to the bottom if you're typing them. Math operators plus, minus, division, multiplication, and modulus. Binary operators, which most of these are. Every one of them, these is a binary operator. It's just that the minus sign can also be a unary operator. Require 2 operands. A piece of data before the symbol and one after. Because you gotta have x plus y, right? Or 8 times 3 or whatever. Escape sequences. Backslash is new line. \n, sorry. \t is tab. \/ double quote is a quote. \/ single quote is an apostrophe. And \/ is a backslash. That's the one you're going to use most of the time. We'll use tab every once in a while as a cheap way of lining data up. What do I mean by cheap way? It's not a perfect way. There's better ways of lining data up on the screen, but \t works. Let me give you an example of when you might want to do that. I'm going to come up here, back to my code, and I should stop and see if anybody has syntax errors. Anybody got syntax errors that you'd like my eyes on? Let me come look. Sorry guys. Language. But what is a pointer? A pointer is an address. I have a house, but my house has an address. If I want you to paint my house, I could give you my house, right? I could pull it out of my pocket and hand it to you. Or I could give you the address of my house. So the way you declare a pointer is you use an asterisk when declaring it. So if I do this, int px, x is a variable, right, declared there. Px is going to be a pointer to x. It's going to be where it is stored in memory. So how do I get that address? I use a different operator, the ampersand, the reference operator, or the address operator. So when I do this, px equals ampersand x. What that's saying is I want you to take the address of that variable and store it in this variable. And by the way, px is not an integer, it's a pointer to the integer. Just like my address. I could write down my address and I could pass it around. So let's print out px and let's print out x and see what they look like on the screen. Cout less than px, and I want a space between them, right? Less than, quote, space, end quote. Less than x, less than ENDL. And are all those spaces necessary? No, only that one. Now I'm going to run it. And I guess I really don't need the line hello there. All right. This address is where that variable is stored in RAM. And we could change it if we wanted to. We could change that value without even touching the x variable. We could do this. We could say star px equals 88 semicolon, and let's print it out again. I'm just going to copy that entire print statement. So I'm telling it, go out to that address and write 88 on it. Just like I could give you my home address, you could go to my house and you could paint the house red, right? I didn't give you my house, I just gave you the address. This is not actually the x variable at all, right? I didn't set x equal to anything. You don't see x equals 88. But it's setting the value that's stored at that pointer. It's setting the value that's stored at that address to 88. So I'm going to print it out again. And what I'm going to see is that the memory address is unchanged. But the variable x has now magically changed to 88, even though I never changed it here. Right? So let's run it. All right, and so that x is stored at memory address 1900 whatever, and it currently contains the bytes that add up to the number 7. And then next time I print something out, the memory address that contains the data 88. So that's what a pointer is, and you can pass data around by pointer as well as passing it around by variable name. Now, why would you want to do that? It makes the code harder to read. Yeah, it certainly does. What if we did something dumb, like add? I'm going to deliberately break my code, so I don't really want you to do this. I'm going to undo it. It blew my code up. Unhandled exception at blah, blah, blah. Access violation, writing to this location. Why? Because I gave it the wrong address. I gave it an illegal address. It's like I told you to go paint my house, but I gave you the address of the White House. You'd go get trouble when you took your paint can to the White House. I'm getting into trouble because now once I made that mistake, it goes into debugging mode, and I'm going to have to get it out of debugging mode. So I would click debug, stop debugging. Well, anyways, so I gave it the wrong address. I added it, I added 9999 to the address, which is not part of memory that this program is supposed to access. It used to be in olden days that you could write to any memory in the computer that you wanted to, whether your program owned that memory or not. And so your programs could edit each other's memory. They could be sneaky. They could look at each other's memory. They could crash the program by writing to the wrong place in memory. Nowadays, operating systems like Windows try to put a lid on that kind of that behavior. So they try to watch to make sure that your program is not trying to read or write to data that's outside of its memory address, legal memory. But sometimes it still happens. If a program can get what's known as ring 0 access, if it can get high level access, it tells the chip, oh, I have write. I'm so cool, I should be able to write to any area of memory. And so if it has elevated access, it can access memory outside your program to go and modify something it should. And so when you're writing, not that we are, but that's how some Trojan horses work. right? Is they get access to something and then they manage to elevate their privilege level so that they can go and change something that they shouldn't. So anyways, that's a pointer. I wanted to give you an example of a pointer. So why in the world would we use pointers if they're so dangerous? You would use pointers because passing data around by pointer is faster, quite often, than passing data around by value. Not for simple numbers like these, right? An integer is only 4 bytes long, and a pointer is probably 8 bytes. So it's more expensive to pass around that pointer than it would be just to pass the 4 bytes of the value. But what if this was some kind of data type that was 2,000 bytes long? It's easy to make a data type that's 2,000 bytes long. And if you wanted to pass that data to a function, it would have to copy all those 2,000 bytes into the function. But if you could pass it in as a pointer, you're just writing an address, right? You're passing in those 8 bytes. It's like I hand you a little piece of paper with my address in it, rather than giving you my whole house, or giving you the address at Walmart rather than handing you Walmart. It speeds the program up a lot if you can use the idea of pointers. Now there's a much safer alternative to pointers that was implemented in C++ called references. So C, the original language, had pointers. C++, grandfathers those in, backwards compatibility, but you're recommended to use another technique called references. And we will certainly address the idea of pointers and references again. Ew, have I used up the entire day yet? The entire lecture period? I just about have.